Okay, so on to the next couple questions from the Honors Pre-Calculus B semester exam review. We're going to start off with number 36. So this says, the percentage of an adult height obtained by a boy x years old is modeled by the function f of x equals 29 plus 49, excuse me, log base 10 of x plus 1. So x is the, just make a note here, x is the years old. So f of x is the percentage. So that's a percentage. And part A says, approximately what percentage of his adult height is a 9-year-old? So that means x is 9. So if I plug in 9 here, it's a simple evaluation of a logarithm. And this guy here, log base 10 of 10 is 1. So really I have 29 plus 49, okay, which is 78, which is our percent. So that's part A. Part B, at what age, corrected 3 decimal places, will a boy reach 90% of his adult height? So this time we're setting 90 equal to the function and finding at what age, in other words, solving for x. A simple logarithmic equation, divided by 49. Okay. So 61 divided by 49 is 1.245 equal to log base 10 of x plus 1. Do 10 raised to whatever on both sides, so that these cancel. 10 raised to 1.245, if you use your calculator, 17.575, and then just subtract 1. So x is 16.575 years. Okay, so that is your part A and B of 36. Let's keep going with 37. Okay, so 37, we're going to get back into some graphing. So it gives us this function here, g of x equal to negative ln x plus 2 minus 5. And actually, to do this, I'm going to practice with just graphing the natural logarithm itself and then use the transformation. So if I let f of x be the parent function ln of x, we can kind of compare here. So this is a, if you don't remember, this is shift left 2 units. This is shift down 5 units. Okay. And then we have this negative, which is a reflection over the x-axis. Okay, so let's go ahead and graph the f of x function. Just to, again, just for practice sake, just to compare f of x and g of x. So here, if this is the graph for f of x, ln of 1 is 0. The point there. Ln of e is 1. We have a vertical asymptote at 0. So here's the natural logarithm. And then we are going to this graph for g of x. So for g of x, it's f of x reflected over the x-axis, shifted left 2 units and shifted down 5 units. So again, I just graphed f of x, the parent function ln of x, just to, for practice sakes, to compare the two graphs. But you can also just plug in some test points to figure out what this looks like. First of all, you should notice that there is a vertical asymptote at -2, because anything past -2 gets me a ln of a negative number. So we have that vertical asymptote. If I plug in -1, so g of -1, you would get negative ln of -1 plus 2 minus 5. Okay, ln of 1 is 0, so you get -5. So I have a point at -1, -5. Okay, and then to get another point on this graph, you have to kind of be smart about the point you pick. I'm going to pick the point e, let's see, e minus 2. Okay, so let me write that a little bit better. So if I plug in e minus 2, e is Euler's number, that is approximately 2.718. So e minus 2 is 0.718. So if I do g of e minus 2, I have negative ln of e minus 2 plus 2 minus 5. So these go away. Ln of e is 1, so really I have -1 minus 5, which is -6. Okay, so if I go on here, e minus 2 again is about right here somewhere, and then I'm down at -6. Okay, so roughly, if this is -6, somewhere down here, so the graph is going to look like this. Okay, just kind of a sketch. And so the questions that they're asking here are, what is the domain and range? So domain is going to be x is greater than -2, because it's everything to the right of -2. My range is going to be all real numbers. Okay. And what else they asked for? Domain range. B, what are the equations of the asymptotes? Well, those we already have on here. So there's a vertical asymptote at x equals -2, so it's a vertical asymptote. Okay. And then part C, describe the transformations. This is also why I graphed f of x. Part C is actually already up here. Reflection over the x-axis, shift left 2 units, shift down 5 units. Okay, so there's number 37. So that one was pretty involved, but it's good practice with graphing. Okay, let's look at number 38. Number 38 gives us a logistic function. $30,000 over 1 plus 19e to the negative 1.5 t. Okay, and this describes the number of people, f of t, that become ill with the flu t weeks after its initial outbreak. Okay, so part A, this is actually just a recognition of the numbers in the function and what they represent. So how many people are ill when the outbreak first began? Here, I know that that means that t is 0. So if I plug in 0, okay, I'll get the following. Okay, this will give me e to the 0, which is 1. Okay, and then if I divide by 20, I get 1,500 people. Okay, so there is part A. Part B. After approximately how many weeks are there 10,000 people ill? So now I'm going to set everything equal to 10,000. Okay, I'm going to solve for t. So to do this, the first thing I'm going to do is actually flip everything. So I'm going to flip both sides, which is equivalent to just multiplying on both sides by this denominator here and just rewriting some things, so I'm just going to save some time and do this. Okay, and then I'm going to start to do some algebra. So multiply by 30,000 on both sides. Whoops. So 30,000 divided by 10,000 is 3. Okay. Then I'm going to subtract 1. Let's move this over here. 2 equals 19e to the negative 1.5t. Okay, divide by 19. 2 divided by 19 is 0.105. Equal to e to the negative 1.5t. I'll take the natural logarithm of both sides. These cancel. And then divide by negative 1.5 on both sides. And once you evaluate this guy here, your final answer is roughly, let's see, 1.503 weeks. Okay, which there may be a little rounding error there, but that's the idea, so that's good. Okay, and then the last one I'm actually just going to throw up here on the top. It's actually a very easy question if you know what's represented in the formula here. What is the maximum number of people that can become ill? So if you look at this function as you approach positive infinity, there's actually a maximum that it reaches out at infinity, and that is just the top number, 30,000. Okay, which is just, it'll always be this top number is the maximum for a logistic function. Okay, let's continue with number 39. So number 39, 40, and 41 are all about eliminating a parameter for parametric equations and writing the relationship between x and y. So this first one, we have x and y are both linear equations in terms of t. Here I'm going to write t equals x over 3. Take this, substitute in for this t. So y equals 2x minus 7. So that's number 39. Okay. Number 40 is going to be a similar deal. So x equals 2t plus 4. Y equals 4t plus 5. It doesn't actually matter. If I go back to this one, it actually doesn't matter. You know, if I solve for t for this one or this one, and then substitute in the other one, I'll get the same answer. So here, I'm going to solve for t for this one. So I'm going to say x minus 4 over, well, let me show all the steps. X minus 4 equals 2t. Divide both sides by 2. Take this guy, put it into this t. Okay, and then you have 4 divided by 2 is 2. Distribute the 2. And then combine the negative 8 and the 5 to get this as your final answer. Okay, so there's number 40. And we'll stop with this video with number 41. Okay, this one is kind of interesting. They're still parametric equations, but they involve trigonometric functions, particularly sine and cosine. So whenever you see these, you should always be thinking about, most of the time you use the Pythagorean identity, the sine squared plus cosine squared equals 1, okay? In this case, sine squared of t plus cosine squared of t, or vice versa, equals 1. So what I'm going to do here is I'm going to say x over 5, and I'm trying to set it up so that I can use that identity, equals cosine of t. This one I'm also going to solve so that it's just a trig function. Okay, so it's a little bit different than the other ones. You wouldn't actually want to use cosine inverse and sine inverse here. It would get probably a little bit trickier, a little nastier. And then if I say x over 5 squared plus y over 8 squared, well, using a substitution, this is equal to cosine t. So if I'm squaring that one, this is cosine of t squared. Okay, and then if I square this one, well, that's the same thing as squaring sine of t. And then you can recognize, oh, well, I know that this here is the Pythagorean identity, that's 1. Okay, and then you can just write these out. So what you actually have is an ellipse. So they're not asking for that, but just as a reminder from Algebra 2, probably, this is indeed an ellipse. Okay, so there you have number 41, and the next session we will start off with number 42. Thanks for watching.